Hello guys, in this video we are going to talk about the laws of integer indices. So first of all, we'll have some formulas to be remembered. And the first one, which is the a to the power of n times a to the power of n. When two things times together, you can plus their power together directly. So we have a to the power of n plus n. And then we have the second one, we have a to the power of m divided by a to the power of n, which means I can change it to a to the power of n minus n. So when two things times together with the same base, so the ground number, the base number are the same, then you can plus their power together like this. And if two things divide each other, and the first condition should be the base number are the same, then you can minus the power numbers. And to conclude this one, you can write it as a to the power of m times a to the power of n divided by a to the power of q or p. So you can write it as a to the power of m plus n minus p. So you can combine them. And so for this one, the m and n can be any positive or negative integers. Okay, so the third formula we need to understand, which is a power to a power, like we have a to the power of n, all the thing to the power of n. So when you see a power outside the bracket of the powers, you can times the power together to get a to the power of n times n. So this is our third formula. And for the fourth one, if we have ab times first, and then the whole thing to the power of n, then we can distribute this power n to both a and b. So we have a to the power of n together with a to the power of n. And so the last one we need to know is the a over b to the power of n. Similarly, we can distribute the power n inside the a and b. So we have a to the power of n divided by b to the power of n. And there's something more. So if you have a negative indices, so for example, if we have a to the power of negative n, which means that we can change it to the denominator to have a 1 over a to the power of n. So every time you change a negative power to a positive one, you switch them from the upper part to the lower part. Or sometimes, if we have something like 1 over a to the power of negative n, so the power is on the denominator, the negative power is on the denominator, then we can switch it back to the numerator to get a to the power of n. And the last thing, just a number, we have a to the power of 0, which is equal to 1. So anything to the power of 0 is equal to 1, apart from the a cannot be equal to 0. Alright, so those are the rules or the formulas that we need to be followed in this exercise. So next we are going to talk about the first question here. So the first question gives you 8 to the power of 7 times h to the power of negative 3 divided by h to the power of 6. So first of all, we can write it as equal to h to the power of 7 times h to the power of negative 3 divided by h to the power of 6. So we can using our first formula, which is a to the power of n times a to the power of n to get a to the power of n plus n, which is equal to h to the power of 7 plus minus 3. So 7 plus minus 3, when plus and minus combine together, which will give you a minus. So please remember this. So we now have 7 minus 3 will give you a 4. So in the numerator, we have this is equal to 8 to the power of 4, and on the denominator, we have 8 to the power of 6. Then we can simplify it, becomes 8 to the power of 4 divided by 8 to the power of 6. As the base number are the same again, so we can using our second formula, which is a to the power of m divided by a to the power of n, which is equal to a to the power of n minus n. So that we can write it as this is equal to h to the power of 4 minus 6, which will give you h to the power of negative 2. So every time when you see the negative index, we can change it to positive, but make it to the denominator. Then we have h to the power of 2, and the 1 as the numerator. And after that, we can simplify h squared, which will give you a 64 over by 1. Okay, so that's for the first questions. And now we can move into our second one. So the second one is asking you 3 to the power of negative 2 to the power of 0 times 4 to the power of negative 1 divided by 4 to the power of 2. So first of all, when we have two things, so the base number are not the same, then we can separate them into, we can group the similar first. So which means that we can change it to 3 to the power of negative 2 to the power of 0 times 4 to the power of negative 1 divided by 4 squared. So in this one, we only have the base as 3, and on the right hand side, we only have the base as 4. So we can separate it into two fractions. So on the left one, as I told you, anything to the power of 0 will give you 1, and the inside thing is not equal to 0, so that the whole thing will give you a 1. And after that, we can using our second formula, a to the power of n divided by a to the power of n is equal to a to the power of n minus n. So in this one, we can have 4 to the power of minus 1 minus 2, which will give you 4 to the power of negative 3. Then we're using our negative integer formula. We can change it to positive, but make the whole thing on the denominator to get 1 over 4 to the power of 3. And then you can calculate by 4 times 4 times 4 will give you a 1 over 64. So next question is the third one. So the third question is asking for 2 to the power of 0 times 5 to the power of negative 3 divided by 2 to the power of negative 3 times 5 to the power of negative 2. As what I said before, if we have two different bases, we need to separate them first. So we can separate them as this one and this grouped. So we can write it as 2 to the power of 0 divided by 2 to the power of negative 3 to times 5 to the power of negative 3 divided by 5 to the power of negative 2. So we're using the second formula again. Then we can calculate our answer out. We can get 2 to the power of 0 minus the minus 3. So we keep this minus as well. Okay, we can using this formula directly. As I told you before, m and n can be any positive or negative integer. Okay, so that's what we did, and we times 5 to the power of minus 3 to minus the negative 2. So please be reminded that when we have like 0 minus 3, when they have two minus comes together, we always give you a positive, which means that we can simplify it to 2 to the power of 0 plus 3 times 5 to the power of minus 3 plus 2, which means that this gives you 2 to the power of 3 times 5 to the power of negative 1. And then we're using our negative formula, negative index formula, a to the power of negative n is equal to 1 over a to the power of n. Then we can have our answer should be 2 to the power of 3 times 1 over 5. If we combine them again, then we have 8 over 5 as the answer of question 3. So next one, for question 4, we have 2 to the power of 0 to the power of 9 times 2 to the power of negative 3 to the power of 0 divided by negative 2 to the power of negative 3. So first of all, the base are not exactly the same, right? There's two positive 2, but this is the negative 2. So first of all, to do something, we need to change it to negative 1 times 2, the whole thing to the power of negative 5, isn't it? And so for the upper part, we have this one. So 2 to the power of 0 is equal to 1, and we have 1 to the power of 9 will give you a 1 again, but actually we can use our formula 3, a to the power of n, all the thing to the power of n is equal to a to the power of n times n, which means that on the numerator we have 2 to the power of 0 times 9, and we have on the right hand side we got 2 to the power of negative 3 times 0. So both of this thing will give you 0 as the index, so which means that we can write it as 2 to the power of 0 times 2 to the power of 0 to divide by the denominator. So we can using our fourth formula, which means that by using ab to the power of n is equal to a to the power of n times b to the power of n, which means we can distribute the power n, to both of a and b. So we can distribute this -5 to this -1 and this 2. Then what we have is -1 to the power of -5 times 2 to the power of -5. So on the numerator, we got this one as 1 times 1, and for the denominator, we got this 2 negative index, so we can change it to positive and make the whole denominator on the numerator. Then we have the answer should be 1 times 1 times -1 to the power of 5 times 2 to the power of 5. But this one, -1 to the power of 5, if you realize that if we have -1 to the power of n, if n is even, then it's equal to 1. If n is odd, means that is equal to -1. So, but 5 is an odd number, so the whole thing will give us a -1. So the answer should be just 2 to the power of 5, but with a negative sign, give you a -32. So this is the answer of question 4, and now we are moving to question 5. So question 5, we have -3 to the power of 5 times 3 to the power of -4 divided by -3 to the power of -3. So first of all, we can group this -3 together as they have the same base, so we don't need to separate this time because they got a similar friends. Then we can change it to -3 to the power of 5, and then divided by -3 to the power of -3, and then we times 3 times -4. Then we can separate the whole fraction into two things times together, so we can do them separately. And then we're using our formula 2, a to the power of m divided by a to the power of n is equal to a to the power of m minus n. So we have the -3 as a whole thing to the power of 5 minus the -3, and then we times by using our formula, I think it's 7, so 3 to the power of, so the formula is a to the power of negative power. We can change it to a positive, but make it to the denominator. So we have this is equal to 1 over 3 to the 4. So now we have the -3 to the power of 8, because 5 minus -3, the 2 minus will give you a plus, then we have a 5 plus 3, which will give you an 8. And then we times 1 over 3 to the 4. As what I said before, when two negative number times together, we have a positive number, but now we have 8 negative numbers times together, which is an even number. So finalize, we will have a positive number. Then we can write it as 3 to the power of 8 divided by 3 to the power of 4. And then we're using our formula again, then we can have 3 to the power of 8 minus 4 and give you 3 to the power of 4. The answer should be 81. So on the next question, we have -4 times a third to the power of -2. So in this question, we can using our formula AB to the power of n. We can distribute our power to both of them. We have a to the power of n and b to the power of n. And similarly, because we have a fraction there, we can use a to the power of b. A over b to the power of n is equal to a to the power of n divided by b to the power of n. So remember these two formula, so with that we can using them directly. Then we have, first of all, distribute this -2 power to this -4. So as the negative power is given to both negative and the 4, so we combine them as a whole thing, the whole thing to the power of -4. And then we times 1 to the power of -2 together with 3 to the power of -2. So after that, we can change the -4 to what? We can change it to -1 times 4, the whole thing to a -2, and 1 to the power of -2, we can change it, we can switch them by eliminating their negative powers by using 1 over a to the power of n is equal to a to the power of n. So we can change this negative power to a positive power. So we can just switch them to get 3 to the power of 2 divided by 1 to the power of 2. So in this question, the left part, we can separate them again by using this formula. To there, so distribute this -2 to both of -1 and 4. Then we have -1 to the power of -2 times 4 to the power of -2 times 3 squared, which give you a 9, and 1 squared give you a 1 again. So after that, we have negative 1 to the power of negative 2 is a positive 1. This one will give you a positive 1. So what we left is just 1 over 4 squared by using this formula, and times 9. And we combine them, will give you the final answer is 9 over 16. So now we are moving to the next page, the seventh one. The seventh question is quite easy actually. We have p squared times p to the power of negative 6. We can just using this formula directly to get our answer, which is equal to p to the power of 2 plus the negative 6. As what I said before, plus and minus combined together will finally give you a minus. So the answer should be p to the power of 2 minus 6, and 2 minus 6 will give you negative 4. So the answer is p to the power of negative 4. But as the question is asking for positive indices, so we need to change it back to positive indices by using our formula a to the power of negative n. We change it to the denominator, and then we make it to be a fraction. Okay, so on question 8, we have c to the power of negative 4 times c to the power of 7 divided by c to the power of negative 3. And we can, using our combined formula, a to the power of m times a to the power of n divided by a to the power of p is equal to, we plus the numerator and minus the denominator's power. And we combine them to get z to the power of negative 4 plus the 7, then minus the negative 3. Like when two negative sign comes together, will give you a positive, right? So we have z to the power of minus 4 plus 7 plus 3. So the final answer should be z to the power of 6, because minus 4 plus 7 give you a 3. 3 plus 3 will give you a 6. Okay, now we are going to do the next question, which is asking m to the power of 8 times n to the power of negative 6 divided by m to the power of negative 1. Like, we can separate it into two things because the base are not the same. So we can put it as a to the power of 8 divided by m to the power of negative 1 times the rest, which is n to the power of negative 6. And then we can, using our formula too, a to the power of n divided by a to the power of n is equal to a to the power of n minus n, to give you a m to the power of 8 minus the negative 1 to times, this is a negative power, we can change it to positive, make the whole thing to the denominator to get n to the power of 6. So realize that we change the whole thing to the denominator, but we also change the power from negative to positive. So we simplify it to get m to the power of 9 divided by n to the power of 6. Why this is a 9? Because we changed two negative sign to a positive one. So now we are going to do the question 10. So question 10 is asking x to the power of 0, y squared, all the thing to the power of 5 divided by x to the power of negative 3 times y to the power of 4. So first of all, we can do this as I said before. Anything to the power of 0 will give you a 1. So we have 1 times y squared to the power of 5 divided by x to the power of negative 3 times y to the power of 4. And then we can, using our formula 3, a to the power of n, all the thing to the power of n, the bracket, the power of a power will give you, we can times the power together. So now we have, this is equal to y to the power of 2 times 5 divided by x to the power of negative 3, y to the power of 4. So we can just change this x to the power of negative 3 become x to the power of 3, but moving it to the numerator. Then we have x cubed times y to the power of 10 minus 4. To get our finalized answer, we got x to the power of 3 times y to the power of 6. So that's the answer for the question 10. And now we're going to do question 11, which is k to the power of negative 2 divided by h to the power of negative 2 times k to the power of 4, all the thing to the power of 3. So first of all, using our formula 3, ab to the power of n will give you a to the power of n times b to the power of n. Again, the n is distributed to both a and b. So in the denominator, what we can do is change them to become h to the power of negative 2 times 3 and k to the power of 4 times 3. And then now we can separate it into two groups. One of the group is together with only h, and another group is together with a base as k. So now we have, but please remember that this is 1 over the h stuffs. So we have 1 over h to the power of -6 times k to the power of -2 divided by k to the power of 12. Then the whole thing, we can use our formula, the negative power formula, a to the power of -n is equal to a to the power of n. So we switch from the denominator of a negative power back to a numerator, but with a positive power. So now we have h to the power of 6 times, then we're using our formula, which is a to the power of n divided by a to the power of n is equal to, we minus the power to get this formula. We can solve for this one. Then we can have the answer is k to the power of -2 minus 12. So the final answer is h to the power of 6 times k to the power of -14. But again, this is a negative power. Then we can change it back to the positive power by changing this one to the numerator to the denominator to get h to the power of 6 over k to the power of 14. So that's the answer for question 11. We're nearly there. We have 3 more questions to do. So question 12, we have p to the power of -7 bracket q squared divided by p to the power of -3, all the thing to the power of 6. So now we're going to using this formula again, a over b to the power of n. So we distribute the m to both of a and b, a to the power of n divided by b to the power of n. So what we can get, we keep this p to the power of -7 to get q squared times 6, and then p to the power of -3 times 6. So we're using this formula to giving this power of 6 to both of the numerator and the denominator by using our times. Okay, so now we have p to the power of -7 times q to the power of 12, and now we have a denominator stuff, which is the base is p. So we put with p, then we have p to the power of -18. Then we can using our formula a to the power of n, using a red pen. So a to the power of m divided by a to the power of n. We minus the power by minus the power to get the formula. Then we have p to the power of -7 minus the -18, and then we times q to the power of 12. So be careful, although there is already a negative sign, but as the formula stated that, we still need to have one more negative, which means that when we have 2 negatives combined together, it will give you a plus. So we have p to the power of -7 plus 18 times q to the power of 12. Then the final answer is p to the power of 11 times p to the power of 12. Okay. The last 2 more questions. Question 13, a little bit hard, but we just do them step by step. So first of all, we have a to the power of 5, b to the power of -4, all the thing to the power of -1, divided by a squared b to the power of -6. So first of all, we're using our formula, a times b to the power of n, which we distribute to the power of n. We're giving you like a to the power of n times b to the power of n. And also we can using the formula of a to the power of n bracket out to the power of n, and then we can times the power to give you a to the power of m times n. Then the answer should be, we can distribute this -1 to both of this 5 and this -4. Then we have a to the power of 5 times -1 times b to the power of -4 times -1, then divided by a squared b to the power of -6. So I'm using some brackets to illustrate the numbers. And now we can combine the a's together. Then we have a to the power of -5 divided by a squared times the things with the b. So we have b to the power of 4 divided by b to the power of -6. Then we're using our formula again, the formula 2. A to the power of m divided by a to the power of n is equal to a to the power of m minus n. So now we have a to the power of -5 minus the 2 times b to the power of 4 minus the -6. Be careful that although there's a negative, we still have to using the formula together with this negative. So we have 2 negative signs together, which will give you a positive. So the answer should be a to the power of -7 times b to the power of 10. Then we need to rearrange the a to the power of negative power. We put it to the denominator to get b to the power of 10 divided by a to the power of 7. Okay, so let's move into the last question, question 14, which is 2x to the power of negative 2, y to the power of 7, all the thing to the power of 3, divided by x to the power of 4, y to the power of negative 3, all the thing to the power of negative 2. If you think this is too hard to expand them, when we see any negative power, we can just throw the whole thing to the numerator, which means that we don't have need to consider about this negative signs. So we have 2 to the power of x to the power of negative 2 times y to the power of 7 to the power of 3. Then we times the whole thing on the denominator, and then we take the square. So now we remove this negative power, we change it to the positive, but the thing all in the denominator, we're all moving to the numerator. So after that, we can using our formula, a to the power of m times n is equal to n to the power of m times n. So which means that we can distribute the 3 as a power to both 2, negative 2, and 7. So we have 2 to the power of 3 times x to the power of negative 2 times 3 times y to the power of 7 times 3 times x to the power of 8. Sorry, I need to write it clearly. So x to the power of 4 times 8, y to the power of negative 3 times 2. Then now we can put all the x together with the y. So this is separated as a number, and we got this is x, this is x, this is y, this is y. Then the answer should be equal to 2 to the power of 3, which is give you 8 times x to the power of negative 6 times x to the power of 6. 4 times 8 give you 4 times 2 give you 8. This give you 8. Then we times y to the power of 21, and then we minus 6. So the answer should be 8 to the power of x to the power of 2, y to the power of negative 15. I'm sorry, it's not negative, it should be positive 15. So that should be a positive 15 here, because 21 minus 6 will give you a positive 15. So that's it for today's worksheet. So try to look the video carefully and then do the corrections by yourself. Alright, so you need to hand in tomorrow. Thank you.